Okay, we're covering 8-8, which is the last section of Chapter 8 that we're going to cover. And we are going to solve radical equations and inequalities today. So radical equation is just an equation that contains a radical in it somewhere. And there are steps to follow, just like in rational equations, to solving them. And here are the steps. First thing you want to do is isolate the radical. So you want to get the radical, which in this case is a cubed root, all by itself. And in order to do that, we have to add 2 to both sides for this example. But we want to isolate the radical because the next step, we're going to raise both sides of the equation to the power equal to the index of the radical function. So in this case, our radical index is 3, so we're going to raise or cube both sides of the equation. Why do we do that? Because basically this and the radical index, raising it to the power, they kind of cancel each other out, and we're left with just the variable or the expression underneath the radical, because sometimes it's not just a variable. And then of course make sure you cube everything on the other side of the equation. Often it's more than just a number. Simplify and solve. In this case there's no simplification to do. Well, I guess you have to cube the 2, but sometimes it's much more involved than that. And just like rational equations, you should, by just practice, always check your radical functions because they can have invalid or extraneous roots as well. So we're going to begin by showing some simple examples, and then we're going to go into some of the more complicated examples where we will find extraneous roots. All right, solve each equation. So here's our radical equation. Remember, first thing we need to do is isolate the radical. So here's our radical. This is our entire radical. We need to get everything but that on the other side of the equation. So we're going to subtract 5 from both sides. And then that's going to give us, when we subtract 5, we're going to get an 11. And to undo the square, in this case the radical index is 2 because that's what it is by default, we're going to square both sides. The squaring undoes the square root, so we're left with whatever is underneath the radical sign, which is just x plus 1, and we're going to square the 11, which is 121, and then lastly we're going to simplify by subtracting 1 to get our solution. And you should check, because you will get invalid solutions. How do we check? We just plug in the value in for x in the equation. In this case we get 5 plus the square root of 121 is equal to 16. Square root of 121 is 11. So you have 5 plus 11 is 16, and that does equal 16. So it is a valid solution. Next example, this one is a cube root. So again, first thing we want to do is isolate the radical. In this case we have a 7 that we need to eliminate before the radical is all by itself. So we're going to divide both sides by 7. And 84 divided by 7 is 12. And now we're going to raise both sides by the power of the radical index, which in this case is 3, or cubed. The cubing undoes the cube root, and 12 cubed is 1728. And now we've got to simplify, solve for x. So we're going to add 7, divide by 5, and end up with x is equal to 347. And we want to check. So we're going to plug. That is not the right check. Huh. So we're going to plug in 5 times 347 minus 7, and then all of that times 7, and make sure it equals 84. So I had to check this one out myself. So I plugged 347 in for x here. 5 times 347 minus 7 is 1728. Cube root of 1728 is 12, and 7 times 12 is 84. So we do get 84 is equal to 84. Here is a problem for you to try. All right, a little more complicated example. So we have 2 radical expressions, and because of that we can't really isolate any one radical. One is going to end up with this extra number here. So we're just going to start by eliminating the radical by raising both sides to the proper power. In this case, we're going to square both sides. When you square, we're squaring the square root, but we're also having to square whatever else is there. So we've got to square the 3. So we end up with, this eliminates our radical. So we have a 7x plus 2. 3 squared is our 9, and then 3x minus 2. We get that from undoing this radical here. And now we can start to solve. Distribute our 9. And now we're going to solve for x. This is a linear function, so we're going to isolate the x, add 18, subtract 7x, and that's going to get us to 20 is equal to 20x, and conveniently x is equal to 1. And we are going to check it again. So here we check it by plugging x equal 1. We've got to plug it into both sides of the equation. And this gives us 7 plus 2 is 9. The square root of 9 is 3. And this gives us 3 minus 2 is 1. So 3 times the square root of 1 is also 3. And conveniently, 3 does equal 3. So that equation, that is a valid solution. All right. Here's one for you to try. Notice this is a cubic root, so be careful. So as I said, raising each side of the equation to an even power, so notice this, may cause extraneous solutions. And why is that? And why is it just even? Because odd powers, you're allowed to have a negative value underneath the radicand, but for even roots, like square root or the fourth root, a negative value underneath that root is invalid. And sometimes when we change the equation by raising the power, we can end up with solutions that will make a negative underneath the radical. So that is why we check. So here's an example. Solve this equation. So we're going to solve it the same way, get the radical by itself. In this case it is. So we're going to raise both sides to the power of the radical index, which is 2 in this case, which is an even. This undoes it. This one, don't forget, you're going to FOIL it. Please, please, this is not equal to 25 minus x squared. This is bad. Very, very bad. Okay, so FOIL this. When you FOIL it, you're going to get 25 minus 10x plus x squared. This is a quadratic, so we're going to move everything over to one side of the equation and probably factor to solve it. So I'm going to add my 3x, and subtract my 33, and that gets me, put it in standard form, that gets me to x squared minus 7x minus 8. So this factors of negative 8 that add to be negative 7. It's going to factor into x minus 8 and x plus 1. Set each factor equal to 0, and you're going to get two solutions, x equal 8 and negative 1. And we need to check both of these. So here, x is equal to 8. Here, x is equal to negative 1. Plug them in. Here we're going to get negative 24. This doesn't look right. The x should be gone. So this should not be here. Negative 24 plus 33 is going to give you 9. The square root of 9 is 3. This is going to give you 5 minus 8, which is negative 3. And we're looking at the principal root here. So we're looking at the positive root. So this 3 does not equal negative 3, so this is invalid. So even though it didn't show as a negative underneath the radical, what we got was an equation that wasn't true. All right, over here, when we plug in negative 1, this is going to be 3 plus 33, which is the square root of 36, which is 6. We're going to get 5 minus a negative 1, which is 5 plus 1, or 6. In this case, that is valid, so our solution is going to be x equals negative 1. All right, one for you to solve. Make sure you check it. So it is a positive root, or an even root or even radical index, and that's when you definitely have to check. All right, so sometimes radical equations are written in exponential form. So if we have the radical written in exponential form, so square root is written as something to the 1/2 power, we're going to solve it the same way. To get rid of the 1/2 in the exponent, we're going to multiply by 2, because 1/2 times 2 gives you an exponent of 1, basically removing the radical. If it were 3, 1/3, you would multiply by 3, etc. So this is the same exact type of problem, it's just written in a little bit different fashion. Here we have 2x is equal to 4x plus 8 to the 1/2 power, so the radical index basically is 2. The radical is all by itself, so whatever, again, you have to isolate the exponential component here. In this case, there's nothing else to get rid of, so we're going to raise both sides to the second power. Whoops. And remember, when you square this, you're squaring both the 4 and the x. This basically just turns this to 1 or undoes the radical. So you have 4x squared is equal to 4x plus 8. So here, again, it's going to be a quadratic. You're going to want to move everything over to the other side. Factor of -8, that is -4. So that's going to be, actually, that's right. There was a 4 first. There's a grade GCF. We should always check that first. Greatest common factor of 4. If we factor that out, we're left with this. And now we want factors of -2 that add to be -1. You get this. And they actually show you, if you set each of these to 0, 4 will never be 0, so you're not going to get a solution from that. X minus 2 equals 0, and x plus 1 equals 0, giving you possible solutions of x equals 2 or -1. And we will check them. When x is equal to 2, we're going to get 4. Somehow our line is missing on this one. 4 is equal to 8 plus 8 to the 1/2 power. That's 16 to the 1/2 power, which is 4. 4 does equal 4, so this one is a valid solution. And then we have x equal -1. So we have -2 here. On this side is going to be -4 plus 8 is 4 to the 1/2 power. 4 to the 1/2 power is 2. So we have -2 is equal to 2. That is actually not valid. So our only solution is going to be x equals 2. So remember to check, else you're going to end up with an incorrect answer potentially. All right, a radical inequality is an inequality that contains a variable with a radical. You probably already figured that out. So we're going to solve it like a radical equation, and then we've got an extra step. And the extra step, when we're dealing with our even radical indexes, like this is a square root, we can't have whatever is underneath this, we can't have whatever's underneath the radical, if it's an even index, to be negative. So we have to add a step after we solve it to make sure that we don't get values under here that are negative. So let's start by solving as if it were equals. So we're going to isolate the radical by adding or subtracting 3 from both sides. Now the radical is isolated, so we're going to raise to the radical index, which is 2. That's going to undo our square root and give us, well, we're going to get 2x minus 6 is less than or equal to 36. They added 6, which is where we got to this, and then divide by 2, and you're going to get x has to be less than 21. All right, so x has to be less than 21 for this inequality to be true, but we also know that 2x minus 6 has to be greater than 0. If it's not, it's going to be negative, and we're not going to have a real numbers for our equation. So we're going to find the values of x that make sure that the radical has a positive value underneath it, or it can be 0 or greater. So 2x minus 6 has to be greater than or equal to 0. Solve for x, so add 6, divide by 2, And we see that x has to be greater than or equal to 3. So our solution is this and this. So we're going to put them together. X has to be greater than or equal to 3 and less than or equal to 21. And we can put that into one statement. Well, you can either express it like this or simplify it. X is greater than or equal to 3 and less than 21. So there's just this one extra step that you need to consider for an inequality. Just make sure that you remember to do that for your inequality problems. That completes this last section. Here's your homework. Bring any questions to class.